This is a Focus ARX SD smart meter. This smart meter was manufactured by Silver Springs Network. It has 4 different screens that it shows at various intervals. The meter measures volts, kilowatt hours, cumulative kilowatt hours, and it has a clearing signal that shows all 8s. We are using a Tektronix 492 spectrum analyzer to analyze the output of this smart meter. This spectrum analyzer can go from 100 kilohertz to 90 gigahertz or gigahertz. We are using a dipole antenna which is located about 12 inches from the smart meter.
And can you explain on the trace what we're looking at?
The center of the screen is 909 megahertz.
Okay.
And the top of the screen is 0 dBm level, and each division is 10 decibels. And I think I can turn Is that helpful or not helpful?
Actually, that is. Yeah, I think that. Yeah, so that's a that's more of an indication on the
the vertical sensitivity.
the vertical sensitivity and the horizontal.
And the horizontal frequency, yeah, as well.
Right. Okay.
Yeah, and each horizontal division is 10 megahertz. Whoops. Yeah, 10. That is a meg, isn't it?
Yeah.
Yeah, okay, 10 megahertz.
Now, we don't know how frequently this thing
transmits. There it goes,
there it is.
right in the
That
middle,
was it. Yeah.
right in the middle. And you've got that on screen now?
We recorded that. So that...
Okay, let's increase the...
Now, what did you do right then?
I increased the resolution horizontally so that the next time we see it, it should be wider.
Okay, but it's a very fast pulse.
It sure is. I hope your camera can see that.
Yeah.
Oh, we were going to time it too,
Yeah,
roughly. So
we could do that.
25
yeah.
past.
Well, we can wait for it to show up again. And
But that was right in the middle, wasn't it?
it was, and there's nothing around that seems to be working at that.
No, we've got the sensitivity down so low. See, the top of the screen is 0.
Right.
And minus 10, 20, 30, 40, 50, 60, minus 70 at the bottom of the screen means that it's going to take a very strong signal.
And because we have the antenna so close to the smart meter,
that's why we get such a strong...
We think we'll get such a strong
signal there,
signal.
right?
Okay.
So we think we've captured one of them at a 10 megahertz resolution, horizontal resolution, or division per division.
Right.
The next thing we want to do is get the vertical. You know, that was such a strong signal. Let's decrease the sensitivity once again.
Okay.
Now the top of the screen is plus 10 dBm, where the printing starts at 909 there.
Yeah.
That's 0 dBm.
Okay.
And minus 10, 20, 30, 40, 50. Now the bottom of the screen is minus 60.
Okay.
So maybe we'll capture the whole thing this time. I hope so.
That'd be nice.
Yeah, it would be. Wider, and so that we get to see the top of it as well.
Okay. We're just isolating this into a very small frequency because we think this is the frequency of the smart meter.
It'd be nice if we had a clock on the screen.
Oh yeah, that would be nice. Well, the other thing that would be nice is if we had a storage spectrum analyzer that would store that particular thing that it grabs.
This will store, if I could only remember how to do it.
Oh.
But I think it has to be on the screen for some length of time before I can store it.
Yeah.
There, it went by.
Yeah, I saw it.
And we got the top of it.
Uh-huh.
And
looks like it.
so what we want to do now is move it to the left. You got to, let's see, that was about every 5 minutes, roughly.
Oh, you think it was 5 minutes?
Thereabouts.
Okay. I can tell it pretty accurately. What are you doing now?
I was trying to find another signal to look at so that when I move the trace this way, I know what I'm doing.
Oh, okay.
See, it turned up over here, and I'd like to turn it up in the center of the screen.
Okay.
And I think you turn this clockwise to do that, but without something on the screen to prove that.
Right. Well, we can wait and see if it shows up again.
I know how we can calibrate it, though, after the next one comes by. Because right after it goes by, I want to pull the signal off it for a second.
Okay. Well, it's a cloudy day, and we had to go through some, we were trying, the screen was reflecting trees and the sky, so we actually are situated underneath the garage door, and the antenna's on top of a garbage can because the smart meter is a little bit, well, the smart meter's near the garbage can, on top of the garbage can. Maybe it should go in the garbage can, I'm not sure. This sounds like a ridiculous way to do this.
Well, since all this information is well known to the PG&E engineers.
Wouldn't it be nice if they would tell us?
Well, has anyone asked them?
I'm not sure. I wouldn't mind asking them. And we could say we clocked it at this frequency. Was it correct? We should talk about the fact that this didn't have to be done in this manner. This signal could have been transmitted over the AC line or in through a fiber optic cable. Is that correct?
Yeah, there are various ways you could get that information, but this is cheap.
Other states are doing it that way. For Florida, for example, is sending it's a digital signal. Like what do they sell? Do they send the signal at the crossover point when the AC?
Oh, is it zero?
Zero.
I don't know how that's done.
Okay.